Welcome to the Inland Seas Engineering and Ship Systems. The intention of this session is to offer some familiarity and begin creating mental pictures of the mechanical, plumbing, and electrical systems on board. Please do not let this overwhelm you. You do not have to memorize the contents of this presentation or become an expert at operating and repairing any of these systems. My intention is to begin orienting you to many of the unseen parts of the vessel that are important to her function, so that you may soon be able to identify normal function and appearance. My hope is that it will be helpful for when you start sailing on board by recognizing some of the items shown in this presentation. We sound the tanks at least once a week or more if transiting extensively under motor. It is important that any procedures involving fuel are done carefully so as not to cause a fuel spill, especially one that could potentially make it into the lake. These emergency poles are located outside the ship on the side of the pilot house. This is so that fuel feeding from the tanks to the engine can be shut off without needing to be inside the compartment if there were an engine room fire. The function of these has to be checked regularly. And this is the other end at the shutoff valve inside the engine room. Just like any engine, the main engine aboard Inland Seas has a cooling system in order to remove excess heat that would otherwise cause severe damage. The red line is the path the lake water takes through the pump, heat exchange, and exhaust. The green line shows the path of the coolant from the coolant pump, the heat exchange, then back throughout the engine block and engine head. It is helpful to be familiar with this in case we need to ever track down a suspected leak. Even though this is not our small boat engine, the little water stream is universal, especially among all later outboard models. If you do not see this stream of water, it is best to shut off the motor until the issue can be resolved in order to prevent damage. The bilge is the lowest part of the ship interior where any water inside of the vessel will drain to. It's like the sump in your basement. The bilge pumping system is to remove water from the inside of the boat and even prevent us from sinking. Familiarity with the bilge pumps is important for performing damage control in the event of vessel flooding. The pump in the photo is plumbed into the same manifold as the engine-driven pump. The engine-driven pump is also our fire pump. We also have automatic 12-volt bilge pumps in each of the compartment bilges. These are activated by a float switch, which also activates an alarm. There are also portable hand-operated bilge pumps that can be used whenever needed in addition to the fixed bilge system. The potable water is the water used for drinking and washing. The tanks are under the sole, but they are filled from on deck. Just like in a house, the water is pressurized and filtered. We also have a water heater to supply hot water. All of our wastewater is kept on board in tanks until it can be pumped out, where it is sent to a waste treatment plant. It cannot be pumped overboard because it's not legal, and more importantly, we wouldn't want to swim in that water if we did. The steering system aboard Inland Seas is hydraulic, but it is not power steering. If we were to have a leak in the system, we could potentially lose our steering ability. In that event, we have a backup tiller that can be fitted onto the rudder post if such a failure were to happen. When there's no wind, we use our engine, which is the main component of the ship's propulsion system. It's important to make a mental note of where the prop shaft exits the engine compartment to the outside of the hull. This can be a potential source of flooding if the seal begins to fail, which is why it is checked regularly during boat checks. Inland Seas has what is referred to as a feathering prop. The blades will self-rotate to the necessary pitch when in forward or reverse. When sailing, they will feather or pitch parallel with the flow of water so as not to cause any drag. In this segment, I will explain a little bit about the electrical systems we have on board. The first couple slides gives a simple explanation about AC and DC electricity in case you are new to basic electrical systems. An incident like this can occur from a plug that is not properly seated or from corroded or loose wiring in the receptacle. When hooking up shore power, make sure the cord is properly connected. With many boats, if there is an issue with the shore power wiring, there will be the potential for stray electrical current in the surrounding water. Our isolation transformer prevents this from occurring. Stray electrical current is why it's never a good idea to swim in a marina. There is no way to tell just from looking if some boats have possible electrical issues. We have one large battery for starting the engine and multiple house batteries used for powering lights, pumps, nav equipment, and all other electrical needs on board. When the engine is running, the batteries are charged by an alternator powered by the main engine. The inverter runs off of the house batteries. Power distribution can be found in two locations. The photo on the left shows the panel located in the main cabin port side, just outboard of the entrance to the main head. On the right, the location is in the cabinet under the chart table in the pilot house. DC power is supplied by the battery bank. The batteries are charged by the shore power battery charger when plugged in to shore power. Or they are charged by the alternator when the engine is running. The battery bank supplies power to the DC distribution panel, which then powers DC equipment such as nav instruments and lighting. The battery bank also supplies the inverter, which in turn converts DC to AC power. AC power is supplied through the inverter to the distribution panel, where it then supplies AC appliances such as any plug-in household item. When at the dock, AC power is provided by the shore power connection.